what does the regular product mean over here? So again, to be very clear, when we're multiplying, when we're doing matrix multiplication, we always use, if we're working in R, we use percent asterisk percent. We don't use the asterisk. We don't use the regular multiplication symbol. If I did try using this, notice that we said over here, the matrix product of A and C, that wasn't defined because A and C didn't have sizes that lined up. If I replace the percent asterisk percent with just the regular asterisk multiplication operator, I do get output over here. But the question is, well, how was this output obtained? Let's see what is going on here. So we had matrix A, which I've typed out down here as one, first row is 1, 2, 3, the second row is 4, 5, 6. And we have matrix C, whose first row is 2, 3, 4, and whose second row is 5, 6, 7. And again, I can't do regular matrix multiplication on this product because this first row has 3 elements. This first column only has 2. So the matrix product of A and C isn't defined, but this strange looking product, when I only use the asterisk, seems to be giving me an output. And what I can see is the first value in my output is 2. And that's what I get if I take the first element of matrix A in row 1, column 1, and multiply it by the entry in the same position in matrix C. So I take 1 times 2, and that gives me the 2. To calculate this next value, 6, that came from taking the 2 and the 3, taking their product, 2 times 3, that gives me 6. So what seems to be going on here is to calculate this entry over here, which is in row 1, column 3. I take the entry in row 1, column 3 of A, multiply by the entry in row 1, column 3 of C. 3 times 4, that gives me 12. And we do this position by position. So row 2, column 1, I take row 2, column 1 of A times row 2, column 1 of B. 4 times 5, that gives me 20. And we fill out the rest of the elements in the same way. So just to summarize this, when we use the wrong operator for multiplication, we use the regular operator for multiplication, asterisk. This does not perform matrix multiplication. This performs what we call element-wise matrix multiplication. So it's going to take like the elements in the same position in each matrix, multiply them together, and that's going to give me the value in that same position of the product. So when we take element-wise matrix multiplication, those matrices need to have the same dimensions. And that symbol is denoted with like an open circle. So we denote element-wise matrix multiplication with A, open circle, B, and that kind of new product symbol here means element-wise product. And again, that we just get by multiplying components in the same location, and the resulting matrix is going to have the same dimensions as the 2 that we started with. So this is just illustrating that product above. Here's matrix A, first column 1, 2, 3, second column 4, 5, 6. Here's matrix B, first column is 7, 8, 9, second column 10, 11, 12. Notice that if I try to calculate the product of these two matrices, matrix multiplication, it's undefined because matrix A has 2 columns and matrix B has 3 rows. So that's out of sync. But I can calculate the element-wise matrix multiplication since they have the same size. So that does work out, and you can check the calculations up here. So just to kind of summarize, the main point here is we use the percent asterisk percent when we want to do matrix multiplication. Do not use the regular asterisk for matrix multiplication. That does something else that's called element-wise matrix multiplication, which is usually not what you want to do. So when we're multiplying matrices in the usual sense, we don't put any operator between the A and the B. We just write the two matrices next to each other, and that implies it is the typical matrix multiplication defined in this rather strange way that you might not have imagined. But when we want to multiply matrices in the true sense, use the percent asterisk percent operator and not just the regular matrix or not just the usual product operator. That does something different. Okay, so that is a whole bunch of operations on matrices. We now know how to add and multiply matrices both by hand, and more importantly, we can do that using R. We use the regular plus for addition of multiplication, and we use percent asterisk percent for matrix multiplication.